One of the most common things I fix when working in new code base in C is linking issues. More specifically, overlinking and underlinking. Did you know that the arguments to the linker are actually positional? So the order does matter. You should know, and you will know after looking at these screencasts. But let's get started with setting the basics of compiling and linking. So today we will work in a Linux system, more specifically a Debian system. We have some files that we will work from. It's nothing complex. First file is a very simple C file. And before doing something, we will actually make it even simpler. So what we're doing now is that we include a library, more specifically glib. We create a pointer to a glist object. And we have a main function simply returning 0. Nothing complex. There's a pointer that we're not using and a main function. So let's now compile this. So we tell GCC that we want to compile the main.c file. And of course, running on this, we will fail because we can find the glib header file. For this, we use package config. And we want it to pass us the C flags so we know where to find the header files for glib 2.0. How it works. So what we have now is a main.o file, an object file. Looking in this file, we use object dump to dump the symbols. Here we can see that we have our main symbol, the main function, which resides in the text segment at this address. We also have the list symbol. This is the glist that we created. This one, the global variable list. And we see that this also have an address in memory. So let's link this to an actual executable. If we do it like this, we don't link with the glib library. Will it work? Yes, it does. And I can execute main without any errors. You can see in the return code 0. So how does this work? We can look at the dependencies for the main file. And we see that we don't have any dependency on the glib library, despite that we're using the list object. And even if we're not using it, we can see that it's actually included. We have the list symbol here in the actual memory map. So how this works is that this object is actually just a header construct. It's simply a pointer to a struct, which is defined in the header files. And if we want to investigate this, we can find the definition of the struct. Here we can find the typedef struct glist points to something else. Let's investigate this. See that glist is typed to underscore glist, which is a struct. And everything we have is a pointer to this. So all the information that we need is actually included in the header files. There is nothing that we need from the actual library files. So what now if we modify So let's now modify the main file again. So what we do now is that if list will be set, then we call a glib function a list object. Let's do the compilation again and look at the object file. We can see some differences in the object file now. We still have the main symbol and we have the list symbol, but we can see that now we also have a symbol called glist first, the function that we're trying to call from the glib library. Looking at the address here, we see that the address is 0 and it also says undefined. So this means that we're actually referencing a symbol that we haven't resolved it yet. We don't have the definition for what's the actual implementation of this function. And that is something that we will see if we try to compile the application in the same way as we did before. Now we actually get an undefined reference to this object or this symbol, because the linker don't know where to find implementation for it. So what we need to do now is to tell the linker that we should link against glib to the DO, because this is where that symbol will be found. And now, yet again, we have our main function. You can see that we can execute it and we have a 0 return code, which means that it worked. We can investigate the main file and we see that this time we have a dependency on glib. So it will actually load glib when we try to run the application and find the missing symbols. So the main point that I said I was going to tell you about was overlinking and underlinking and the usage of positional arguments. So when compiling this main executable, we specify the glib in the end of the linking command. So what if we would have placed this in the beginning before the object file? We will see that this still works on this specific setup with this computer. But if you were to run this on a Ubuntu system, you might have seen that it didn't work for you. It will complain about undefined glist first, undefined reference to glist first. So the problem here is that not all GCCs are born the same. When you compile the GCC compiler, there are actually some different things that you can change. Quite a lot of things actually. One thing is in the configure script, you can add different parameters, and we can actually run GCC with a verbose flag. And this prints out configure with. So now we can see what arguments went in to the configure script before compiling GCC. And this might actually vary between different distributions, between Debian and Ubuntu, for example. And we also have something else that is called specs file. This also tells us some different flags that are passed to, for example, the linker from the GCC driver. And with driver here, of course I'm not talking about drivers, but I'm talking about that GCC is just a program that invokes other programs. So it invokes the compiler and it invokes the linker. And the flag that we're interested in here is a flag to the linker. We pass it this way, and it's called as needed. This tells the linker that if the symbols are not needed or the libraries are not needed, we shouldn't link against them. So if we run this command now, it's exactly the same as what got a program compiled before, but now it complains about undefined reference. And if you developed an application and had this in your build file from the beginning, it might have worked on your Debian system, but when someone tries to compile it on an Ubuntu computer, this is what they will see. Because on Ubuntu, normally GCC has the as needed as a default flag, while in Debian, you have the opposite. The default flag is no as needed. So you can see in my case, on this Debian system, these two commands are the same, but this is different. So what do we need to fix this? Well, what we need to do is simply that this line specifying that glib should be compiled into the application should be placed after the object file. It doesn't need to be placed all the way to the end. You could also place it here. It also works. You can see that we have a main file still linked against glib, and we can actually execute it. So what happens here is that the symbol resolution in GCC is done in a single pass. This means that whenever we specify a library, GCC will look at what undefined symbols does we have currently, and can I find any of them in this library. If we first have the object file, this will introduce an undefined reference, or rather reference to an undefined object or symbol. So then when we get to the glib, the glib specification, it will go to this shared object and it will look for this symbol. And in our case, it will find it because this is a symbol in the glib library. But what happens if we place it the other way around is that it will first go to the glib library and look for what undefined symbols does I have. And of course it has nothing because we haven't introduced any undefined symbols. They are introduced in the main object. So this is why it's very important that this should be placed after the dependencies. And this actually introduces a quite a little bit funny thing. If you have circular dependencies, let's say that we have the glib library would be dependent on another library, let's say libffi. But libffi is dependent on glib libraries. It uses symbols from the glib library. What we actually need to do here is to one more time write glib. This means that, sorry, the other way around. This is true. So what else we'll do is that when running the first library, let's actually use other names here to not confuse us with two libraries that are dependent on each other. Let's call them lib_a and lib_b. The first we link against lib_a, and this has undefined references to lib_b. So then we need to specify lib_b, but this has undefined references to lib_a, and now we actually need to specify lib_a again, because at the first pass over lib_a, the references from this library are not yet known. So after they have been introduced, we need to include lib_a again. But before this, of course, we need to include this, because otherwise the symbols from that one won't be resolved. That links against this one. So that's about circular references. So I also said that I was going to talk about overlinking and underlinking. And now we have introduced the aspect of linking against libraries. Overlinking is basically when we link against more libraries than we actually need. And underlinking is when we link toward fewer libraries than we need. Not all of the libraries that we need will be specified in the DT needed section. So all these lines are different libraries that our main application are dependent on. If this is too short, this list, we have underlinking. If this list is too long, we have overlinking. And to best show this, we will compile a shared object instead of an executable. So I have prepared another code file which is called lib.c. And this is exactly the same. We can actually look at the diff. The only thing that differs is the name of the function and the name of the list. So instead of having a main function, we have a getValue function. And this is because the main will be included or defined in our main file, of course, when using the library. So we don't want a main symbol in our library. Instead of compiling main, we will compile lib.c. And we will tell the compiler to make a shared library. We also want position independent code. And output should be lib.so. You can see that now we have an SO file, a shared object. If we look at the content of this SO file with object dump, we can see that it looks pretty similar to what our main object looked like. We have our function, the getValue. It's a symbol with an actual address. And we have our pointer to the lists. It's also a symbol with an actual address. And just as before, we have our symbol for the glib function that we're trying to use, the glib first, which doesn't have an address and it's undefined. So What we also are interested in now is how so I'm actually confused a bit now. The compile command that we ran shouldn't have the C flag, because then we don't compiling a shared object. The only thing we did there was the compilation. Now also done the necessary linking for the shared objects. But basically the things are the same, that we have the list with an address. We have the glist first function. It doesn't have an address, it's undefined. And we have our function getValue, it has an address. But another interesting aspect here is that we have the needed, DT needed. This tells anything that links towards these shared objects what transient dependencies do we have. And one such transient dependencies is specified as libc. Another one should be glib, but we don't have it. And that's because when we did the linking here, we didn't specify it. But actually, let's take a step back to make it clear about what is linking and what is compiling. So just as we did the first time, we added the -c flag here, telling the compiler that we should only compile this. So we don't need a shared flag, because that's just for linking. We do need the position independent code flag, because we need to compile code as position independent if we want to make shared library objects. And the output shouldn't be the SO file, but instead an object file. So now we actually compiled this. And yet again we can use object dump, look at symbols for this. And now this would be pretty much like the main object file, but with the getValue function instead. So linking this to a shared object, we do gcc lib.o. We want a shared library, and the output should be libmylib.so. Now we should be pretty much back to the step from the last time. This is what you recognize from before. We can also look at the needed again. So still, it's just libc. So why don't we have glib here? Well, it's actually because when compiling this, we forgot, or actually linking this, we forgot to tell the linker that we are dependent on symbols from glib. If you do like this, see that now we've actually added glib to our needed section. So this was a case of underlinking. We actually had unresolved symbols from glib, but we didn't specify a transient dependency on it. And this is actually a case of overlinking, and actually this too. This was both overlinked and unlinked. Because libc, what do we use from libc? Well, nothing at all actually. So this comes back to what I showed you before. the linker flag that was as needed in our case in Debian, or this specific GCC that was distributed with Debian. So if we add this flag, we should have no difference at all. Sorry, the other way around. The default in Debian is no as needed. And we see that adding the no as needed flag to linker is exactly as not doing it at this system. At our Ubuntu system, it would probably be different because the default for GCC there would be as needed. So what happened if we compile with as needed? The libc line actually disappeared because it's not needed. libc is a bit special because the compiler tries to add it manually. You don't have to specify the dependency on libc. But that also means that if you don't have a dependence on libc, you might add it. And that could be a bit problematic, and at the very least, it's not necessary. And it's the same with other libraries. If we compile with no as needed, or in my case on Debian, if we remove this altogether, and we add another library here, let's add a libffi. Now suddenly we have a dependence on libffi. This means that if someone wants to be able to use this library, link towards this library, or run an application that is linked to this library, they actually need to install libffi on their system. Even though we never use libffi, we don't have any dependence on it, just because we specified it here on the command line. And this is quite a common problem, and a typical issue with overlinking. And except for actually preventing the application from running if you don't have libffi, it might introduce some extra overhead when running the application or loading the application. But because the symbol resolution will do a breadth first search in all the libraries that is specified in the needed section. So if you have a symbol that you need to find, it will look in libffi's symbol table too, which is totally useless because we don't have any need for it. So the correct way to fix this is, of course, to make sure that your SU file has the right needed specifications. Only what you need and exactly what you need should be specified here. So one way, let's actually first connect this to the issue we had in the beginning with positional arguments, because that might be the number one reason I see to get this wrong. So let's assume we're in a Debian system, which we are, so we can remove this. Now we have something that works different in Ubuntu and Debian, or possibly could, depending on the GCC compiler. And we accidentally put this before the object, so before the glist first function is introduced as an undefined reference. Looking at the object dump again, this looks correct because we're on a Debian system. But if we were on the Ubuntu system, it would probably be more like this, with this as needed flag. And now we see that we don't have any neededs at all. We don't have any reference to glib. So this is a typical problem of underlinking, and probably the most common reason for underlinking. So what if we don't know this, and we distribute this shared object, and then we have someone else that is trying to use this? So let's take our main.o file again and compile it to a main executable. Actually, what we will do is to modify this again. Now we have the simplest of all possible main applications. Just a main function returning 0. Compile this to a main.o file. And then we link this main.o file to compile a main.c file to a main.o file, object file. Actually, what I forgot. Either we can do the compilation link in the same step, and then we get the main file directly, or we can do it in 2 steps. And that's what I tried to do here, but I forgot about the C flag. So actually, let's remove the main.o file again, just to make sure we're done everything correct. And we compile the main.c. And now we see that now we have a new main.o file, a new object file. So now we link this main.o file to create a main executable. And we can execute this. And we can look at main to see what dependencies does it have. Okay, so let's now assume that when linking this, we have a dependency on our library. So what we do then, actually let's introduce a dependency on our library. So let's call the getValue function, and this will actually return an integer value. So let's do it like this. Now we actually have a dependency on our shared library. The getValue function is defined. So yet again, we compile. We get a warning because we have an implicit declaration, but it's an integer value, so it's okay for now. Not good practice, but let's deal with it. So after compiling the main.o file, we try to link it. And now we see that we have an undefined reference to getValue. So let's add our library. I will also have to tell the link to look in this folder for it. So here, now we see that now instead we get undefined reference to glist first, which is the glib function. So since we know that it's a glib function, of course what we could do is add here, tell the linker that we should also link towards glib 2.0. And now it works. The application works. And looking at the dependencies for main, we can see that we have the dependency on mylib and we have the dependency on glib. So this might look good. And this is a very common thing that I see, that you first do a mistake when you compile the shared objects and forget to link to the right things there. And then you fix it by adding the dependency on that library when linking the main application. And first of all, this is not how it should work, because someone using the library should not need to know any internal things about the library. We shouldn't need to know that the library is dependent on glib and specify that. That is something that the developers of the library should do. And secondly, this actually mixes together transient dependencies and dependencies directly for the application. So if we do an object dump and look at the symbols in main, and we look at the needed, we can see that now we have glib as needed from our application. And if this was just a transient dependency, which it should be, then it shouldn't be specified here. But it should instead be specified in this file. And this is where the breadth first search for symbol resolution comes in. So this actually does make a difference where the dependency is specified. So the correct way of doing this is not to add the glib dependency here when we compile our main application, because the main application doesn't have a dependency on glib. It's just an internal function, internal workings of the library. So what we need to do is correct this in the libmylib.so. First of all, one way we could do it, if we don't have control over this. This is not necessarily a good way to do it, but you can always modify an SO file. So for example, you can use something that is called shelf. This is a post-link elf editing tool, which allows you to edit files post-linking. So what we should do here is specify that we want to add a needed. And what is needed? glib to the O. This file is actually needed. And we want to add this to the needed section of our libmylib. But before doing this, let's again look at the needed section of libmylib. So now we don't have anything. It doesn't specify a single transient dependency. If we now run this command, we can see that now we have actually added a dependency to glib. So now we can try to compile our main application again. And now we don't have to specify glib here. So let's just do it like this. We look at our main. Now we still have a dependency on glib. That's good, because now we didn't need to know that we had a dependency, because it's just internal of the library, and we get it here. But how about where it's specified? Look at the object dump for main, and look at the needed section. We see that the only thing we need is libc and libmylib. And the last time we did this, we also had glib here. And this is good actually, because now the dt needed in the main elf file, just specify the direct dependencies. And then the transient dependencies is specified in this file. So that's exactly what we want. But we don't want to modify the SO file after creating it. So let's remove that file and we'll go back to the compilation. So the problem we did was that we had the glib before the object that introduced the undefined symbol. So to avoid things like this, we can actually add another argument here to the linker. If we do like this, we will see that it refuses to compile the SO-lib because we have an undefined reference. So what this does is actually to tell the linker that we should not accept to link something where we are trying to use symbols that we don't have a reference to. So what we need to do now is just to move this to after the object file. So now we can see that now we automatically get the needed libglib. So this correctly defines specify the transient dependency. And of course, now we can also compile the main application without specifying glib. And we will see that it does link to glib. If we look at it in the needed section, it is not specified in the main, but we get it here. And this is because this is after doing a recursive resolution of also the transient dependencies. It will first look at the needed section in this one, and then it will go on and look at the needed section in this one and find this one. And then of course it will go further and look at the needed of this one and of this one. And this is how all this is created. So now we have learned about linking. Now you know what difference are there between Debian and Ubuntu, for example. Or more specifically, what difference are there between GCCs that have been configured in different ways, either from the specs file or from the configuration script. And you know why it is important. So you don't only know how to correct these kind of issues now, but you also have gotten some ways to investigate if this is correct by not only using LDD to find the dependencies, but also looking at the needed section of each object file and each SO file and each elf file. So hopefully now you can produce better code that is more portable and more efficient.